the important thing is the limit, continuity and differentiability. So now we have to read, that is limit in complex analysis. So limit, so when we say that its limit exists or not, so if fz be any function of complex number or complex variable. Okay, so fz be any complex be any function of complex variable. So if z0 belongs to D, then limit z tends to z0 f of z, if this limit is exist, then we said that that is exists finitely, then we said that its limit exists. And another definition is what is that? That is epsilon delta definition. So if limit z tends to z0 f of z, this L, where L be any finite number, so then so if for all epsilon greater than 0 there exists a positive number, that is delta, there is exists a delta which also greater than 0, such that f of z minus L, this mod of this less than epsilon whenever z minus z0 this less than delta, then we say that its limit is exists finitely. So now some application of limit, जो कि हमेशा ही क्वेश्चन आता है और गेट और जैम में भी तो आता ही है, और नेट में कभी कभी वैसे आपको डायरेक्ट नहीं पूछेगा कि इसका लिमिट क्या होगा, आपको जो है घुमा के क्वेश्चन मिल सकते हैं. तो चलिए कुछ एप्लीकेशन हम करते हैं. So here one question is, the limit z tends to 0 z by z bar, its limit exists or not. So its solution, what is that? We know that in a complex number system, or that is in our first lecture, and that is z is equal to x plus iy, and similarly we have that is z bar is x minus iy. अगर ये कैसे आपको पता नहीं है तो आप लोग जो है पहले वीडियो देख सकते हैं. तो चलिए, सो z is equal to x plus iy and z bar is equal to x minus iy. So now limit z tends to 0, that is what is z here, x plus iy, and this here x minus iy. So this equal limit z with the what is this, the function of, that is z is the combination of x and y. So this x comma y is tends to 0 0. Here z is 0, that is हम यहाँ समझाते हैं, जो कि z अगर 0 है और हमें z पता है x plus iy, this equal to 0 plus I into 0. So this implies x is equal to 0, y is equal to 0. So ordered pair in xy can be written as 0 comma 0, and here this x plus iy as usual x minus iy. So now putting, that is here one transformation, this is putting y is equal to mx, then as x tends to 0, that is from here x tends to 0, y tends to 0. So here x tends to 0, we have y टेंस टू 0. So तो ये this x tends to 0, this x, so x as usual, and y is equal to mx, so I into mx and by x minus I into mx. so here तो ये कैसे है, ये जो है आप लोगों को कैलकुलस चैप्टर में आप लोगों को जो है पढ़ाया जाएगा. तो चलिए इसको अभी आप जस्ट जान के रखिए कि यहाँ से ये कर सकते हैं. दिस 0 here x common, so x 1 plus I into m, and here also x common 1 minus I into m, so x cancel, so here a limit x tends to 0, 1 plus im 1 minus im. so here x यहाँ पर कोई x नहीं है तो ये x कांस्टेंट है, तो कांस्टेंट जो है लिमिट से बाहर आ जाता है, तो कांस्टेंट जो है वो बाहर आ जाता है. तो यहाँ पे 1 प्लस आई एम 1 माइनस आई एम. सो दिस तो ये कोई भी वैल्यू कोई भी फिक्स्ड वैल्यू नहीं रहता है. ये अगर m का वैल्यू डिफरेंट होता है तो ये वैल्यू भी डिफरेंट होता है. तो यहाँ पे डिफरेंट वैल्यू फॉर डिफरेंट m. सो हेयर हम क्या कर सकते हैं यहाँ पे, तो ये कह सकते हैं कि इसका जो है लिमिट एग्जिस्ट नहीं करता है. सो इट डज नॉट एग्जिस्ट एनी लिमिट. ओके, चलिए दूसरा क्वेश्चन लेते हैं. सो यहाँ पे जो है सेकेंड क्वेश्चन, लिमिट z टेंस टू 0 z बार इट्स स्क्वायर, व्हाट इज दैट वैल्यू. सो solution here given that is we know that z is equal to x plus iy and z bar is equal to x minus iy. so now z bar its square means x minus iy its whole square. so this x square a minus b whole square, this is 2ixy plus iy its square. so x square minus y square minus 2ixy. so ये जो है तो अभी लिमिट, सो नाउ लिमिट z टेंस टू 0 mod z bar square, दिस इज इक्वल टू लिमिट जो है प्रीवियस एग्जाम्पल से हम ये लिख सकते हैं x y टेंस टू 0, 0. so this will be x square minus y square minus 2ixy. so again we put y is equal to mx and then x tends to 0 as y tends to 0. then फिर से single limit this x tends to 0 and this x square y means mx, so y square is minus m square x square, and here minus 2ix and y is mx. so this will be limit x tends to 0 and this x square minus m square x square minus what is that, this m into x. so this will be 2im x square. so limit x tends to 0 x square will be common, so 1 minus m square minus 2im. so now here x is here, so we are putting the value of x, this 0. so if 0 multiplied by any numbers will be 0, so this will be 0. so hence limit z tends to 0 z bar square this is equal to 0. so इसका जो लिमिट है वो 0 में कन्वर्ट करता है. चलिए एक और क्वेश्चन जो है उसको हम सॉल्व करते हैं. So here question number 3 is limit z tends to 0 e to the power minus 1 by z. What is that? So now this, okay, so question number 3 is limit z tends to 0 e to the power minus 1 by z. What is the value? So यहाँ पे जो है हमें सबसे पहले पता होना चाहिए e टू द पावर x का एक्सपेंशन और e टू द पावर माइनस x का जो है एक्सपेंशन, जो कि आप लोगों को टेलर सीरीज एक्सपेंशन में आप लोगों को मिल जाएगा। तो अभी आप लोगों को जो है ये याद रखना पड़ेगा। तो e टू द पावर x का जो एक्सपेंशन है वो है 1 प्लस दैट इज x, ओके, सो 1 प्लस x स्क्वायर बाई 2 फैक्टोरियल प्लस एक्स क्यूब बाई 3 फैक्टोरियल, दिस ये जो है चलता रहेगा। और e टू द पावर माइनस x का जो एक्सपेंशन है वो है हमें 1, जो कि प्लस माइनस अल्टरनेट करेगा। तो 1 माइनस एक्स प्लस एक्स स्क्वायर बाई 2 फैक्टोरियल, दिस इज 2 फैक्टोरियल नॉट 21, दिस माइनस एक्स क्यूब बाई 3 factorial, this plus x to the power 4 by 4 factorial minus, so this be the expansion of e to the power x and e to the power minus x. Okay, so now here is given that e to the power minus 1 by z. What is that? So here this term, so ये जो है e to the power minus x का टर्म का है, तो हम इसे लिखेंगे 1 minus x means here 1 by z, so 1 by z plus 1 by 2 factorial into x square means 1 by z square, so ये चलता रहेगा। तो now limit z tends to 0 e to the power minus 1 by z, this is equal to limit z tends to 0, here 1 minus 1 by z, जो कि e to the power minus 1 by z का एक्सपेंशन है, उसे हम यहाँ पे रिप्लेस करेंगे। So here we replace the value of this here, so plus 1 by 2 factorial into 1 by z square, so ये जो है वो यहाँ पे माइनस ये चलता रहेगा। ओके, सो नाउ लिमिट z टेंड्स टू 0, दिस हेयर 1, जो कि लिमिट को हम इसको सेपरेट कर सकते हैं इजी, सो हेयर वी इजीली सेपरेट द लिमिट, सो इट इज माइनस दिस, सो लिमिट z टेंड्स टू 0 1 by z प्लस 1 by 2 फैक्टोरियल लिमिट z टेंड्स टू z 1 by z स्क्वायर, सो ये जो है एंड सो ऑन। सो नाउ this value will be 1, this is constant, and here z tends to 0, and here the function is 1 by z, so 1 by 0 is undefined, so here this does not exist, so this does not exist, so now this also will be does not exist, hence the limit of this is does not exist। ओके, तो ये जो है लिमिट का 3 क्वेश्चन हो गया। अभी हम पढ़ेंगे कंटिन्यूटी। सो अनदर इम्पोर्टेंट थिंग इज कंटिन्यूटी। सो व्हाट इज दैट? a function f, let f be any functions f that is d to c, where d and the subset of c. Okay, so and z0 be any point belongs to d, then f, that is functions f, is said to be continuous at point z0 if the limit z tends to z0 f of z, this f of z0. So if be any functions which is d to c and z0 be the any point that is z0 which belongs to z, D. Then f is said to be continuous at z0 if limit z tends to z0 f of z, this will be f of z0. Then f is said to be a continuous functions at the point z0. So here some examples. So here this one example is that is f of z is equal to z, check at z0 as equal to 0. So 0 पॉइंट पे ये कंटिन्यूस है कि नहीं ये चेक करना होगा. तो चलिए बाय डेफिनेशन हमें सबसे पहले जो है कर लेना है. चलिए सॉल्यूशन. सो हेयर गिवन एफ ऑफ जेड, सो लिख लेते हैं गिवन एफ ऑफ जेड इज इक्वल टू जेड. Then लिमिट z टेंस टू 0, दैट इज यहाँ पे z टेंस टू z0 और यहाँ पे z0 गिवन z0 इज इक्वल टू 0. सो it will be z is equal to 0. f of z means, sorry, so we have to put here the value of z, so this will be 0. So here this now f of 0 means 0. So here satisfied limit z tends to z 0, and this is f of z, this is equal to f of 0. So here f of z is equal to z is continuous at z0 equal to 0. Now another example is so here another example is f of z is equal to z bar. So check at z0 is equal to 0. So we know z is equal to x plus iy and z bar is equal to x minus iy. So again limit z tends to 0, this z bar, so this is equal to limit z tends to 0 z bar and this x minus iy. Here this limit x y tends to 0 0 and this x minus iy. So now again we are putting y equal to mx, then limit x tends to 0, this x minus I into mx, so this will be x, limit x tends to 0, this x will be common and this 1 minus im. So here we put the value of x, then will be 0. So this is also the continuous at z0 is equal to 0. For y here this f0 is equal to 0 bar means 0. So this is the continuous. So here another example is if f of z is sine of z minus 1 by z minus 1 when z not equal to 1 and 1 when z is equal to 1. Our question is this fz is continuous or not at point z equal to 1. So solution. Okay, so given this, so now we have to check the limit z tends to 1 f of z, this is equal to if f of 1, then we say that the function f is continuous at point z equal to 1. So now show limit z tends to 1, this f of z, this limit z tends to 1, f of z means this point z not equal to 1. So this is sine z minus 1 by z minus 1. So here we put z minus 1 is equal to u, and when tends to 1 we have u tends to 0. So limit u tends to 0, sine of u by u, this is equal to 1, and this is equal to f of 1. So hence it is continuous at the point z equal to 0. दिस वैल्यू, इसका जो वैल्यू है वो 1 आएगा, जो कि हमने एच में पढ़ा है. So here given functions is continuous at the point z equal to 1. So today lecture is over. Next lecture we will see the differentiability, important things, then analyticity, and that is Cauchy-Riemann equation, singular point, regular point, etc. For any query, these related videos or any problems, then post the comment section. Thank you.